Okay. So 7.1 is angles, arc length, and circular motion. Circular motion. All right, so first let's talk about like the orientation of the angles. Usually the angles will start this way to be called the initial side. Then it will sweep in this direction. Let's say it goes right here. Counterclockwise. This will be the terminal side. Make that a little prettier. So going counterclockwise is considered to be positive. Going clockwise is negative when it comes to angles. I know that's a little weird, but that's just how it is. So this is a positive angle. Counterclockwise. Now, if I start at the initial side, but I go this direction, even though I'm in the same place, but I went this way, that would be a negative angle. So this is still the terminal, still the initial. This would be a negative angle. Clockwise. Although the angles would be considered to be equivalent, which we'll talk about later on, even though if I end up in the same place, but I use different directions, they're technically the same angle, especially when you put it inside of a function. But you can spin around over and over forever and find infinite angles that end up at the same place. So they're equal, yet sometimes they're not. It really depends what we're talking about. It really depends. Another idea I need you to remember is the names of the quadrants. Those are going to keep coming up. So again, going counterclockwise, this is the first, the second, the third, and the fourth quadrant. Quadrants of the XY plane. I'll make that bigger. So this is just X and Y quadrants of XY plane. This is still the X and Y coordinates. Okay. In the homework, they're going to ask you like, what is here we go. Which quadrant is this angle in, etc. Okay. Let me find some good examples. One counterclockwise revolution is equal to 360 degrees. 1 degree is equal to 60 minutes. 1 minute is equal to 60 seconds. We refer to this in the book and in the homework. You'll see this. They'll mention it this way: degrees, minutes, seconds. And they'll ask you to convert back and forth, which we'll do a little bit later. Okay. Excuse myself. Arc length. For a circle, of radius r, a central angle of theta degrees. Actually, let's see, that should be radians. Theta radians. Subtends an arc whose length s is the following. So when they ask you in the homework, which we'll do in a minute, a bunch of examples. For arc length, your theta needs to be in radians, which we'll learn about converting in a moment. One revolution.
What does that say after radians?
Subtends.
Okay.
It's like just sweeping across, which I'll show you a picture in a second. One revolution equals 2 pi radians. (180 degrees) is equal to pi radians. Which means that 1 degree I'll just put the symbol better. 1 degree is equal to pi over 180 radians. We're going to need all these formulas later. And 1 radian, or sometimes called rad, is equal to 180 over pi.
So 1 degree equals 1 radian?
Kinda. So these are similar, but I'll show you how they're used.
Or the inverse?
Yeah. So we're going to be using one or the other to convert. So if you
Okay.
have 1 degree, you multiply by this guy, and you'll be left with radians. But if you have a rad, you multiply by this, and you convert to degrees.
Gotcha.
Let me grab some examples now. I think that's all we need. Oh, wait, one more. All right. Area of the sector. Area of the sector A. I should rephrase it. Yeah, I'll just start there. There's a definition with the formula. The area A of the sector of a circle of radius r formed by a central angle of theta radians. So again, if they ask for area, theta needs to be in radians. Your angle needs to be in radians. Is the following formula. So A is equal to 1/2 r squared theta. Okay. Okay. So to convert to radians, multiply by pi over 180 degrees. So this is a form of 1, but it's also called a conversion factor. So this will cancel out the degrees, leaving you in radians. So you take the 45, you multiply by pi over 180, right? Technically, if you did the fraction multiplication, you'd end up with 45 pi degrees over 180 degrees, right? So there's a invisible 1 down here. So these degrees are going to cancel. Kind of like we had feet over feet, right? It's no longer feet. So they're going to cancel out, and now all we have to do is reduce the fraction. So reduce 45 over 180. What's that going to be? We'll just leave the pi to the side.
4.
Yeah.
Be 1/4.
Yeah,
Or 1.
Yeah, you're right. So this completely cancels, leaving you with a 1. This reduces to 4. Pi over 4. So 45 degrees is the same as pi over 4. I also sent you a unit circle in your email or Canvas inbox. They have the common angles in both degrees and radians. Do you have any questions on the first problem?
Can you repeat the where you got the 45 over 180? Why you cancel it out?
Okay, so I'm taking, this is the question right here, right? We're given 45 degrees. They're telling us to convert it. So you're going to multiply by the conversion factor.
Okay.
It's kind of like, let's do an easy example, back to basics. Let's say you had 1 foot, right? And you want to change it to inches. The official way you should do it, and we know the answer, so that doesn't matter. What you would do is say, okay, there's 12 inches per 1 foot, right? let's make it more interesting. Let's say this is, I don't know, 4. Okay. So then you would multiply straight across like you do any fraction. So feet are going to cancel,
Something like that. Okay.
leaving you with 4 times 12 over 1. But this is the inches unit is still there. So we will have 28 inches, which we need the answer, right? 4 feet has, actually I messed that up. How many inches in 4 feet?
48.
48.
48. There you go. Do you see the general idea? It's the same thing
Yes.
here.
Yes. Mhm.
So the degrees are going to cancel, and then you multiply straight. 45 times pi over 180, and you reduce these guys. So if we show an extra step here, y is at pi over 4, we'll factor 45, right? 45 is 9 times 5 times pi. 180 can be reduced to what? Let's see here. 9 times 2 times 10. So these 9s are going to go away. This 5 will divide into the 10, leaving me with a 2. 2 times 2 is 4.
Okay.
Or you can try to think about what is the smallest number to divide into both. However you want to think about it. It just goes back to the fraction rules, right?
So that would be your answer, pi over 4.
Yeah, this is the answer. Box that answer.
I had a question where we put 45 pi. So what I did in the calculator, I actually times it by 3.14. So what pi is equal to. But in this case, it's only equal to 1, right? Or
Yeah, since, well, if you multiply the pi in, it's no longer exact because pi is a irrational number. It's going to go on forever, right?
Yeah.
The 314, you're rounding it, so we no longer have an exact answer. We have an estimated answer. So just leave the pi alone and deal with the numbers, and then
Okay.
then just tack it on at the end.
okay.
Because if you use your calculator, I mean, if you can still use your calculator if you want, but just use your calculator on the 45 over 180. That's it. And just remember, there's still a pi there waiting for you. If you want to reduce a fraction with your calculator, that would be one way to do it.
And do we just drop the degrees just because there was degrees on top and bottom of the arc symbol?
Yeah, exactly. So it's like you canceled out the unit degrees. Now I'm in radians.
Okay, thank you.
Mm-hmm. Although radians is considered to be unitless, but let's not worry about that right now. Okay. Let's do convert the angle in radians to degrees. Here's the question. Let's make one up here. Pi over 2, I guess. So here's the instructions. So to convert to degrees, multiplied by the opposite of this guy, 180 degrees over pi. So this time I want to cancel the pi and be left with degrees. So here we go. Here's pi over 2 multiplied by 180 over pi. So these pi's are going to cancel out, right? So let's show a step. 180 times pi would just be 180 pi over 2 pi. So these guys will cancel. And 180 degrees divided by 2 is going to be 90 degrees, which is our answer. So you need to choose the correct conversion factor and then convert. There we go. All right, so we're going to convert the minutes first, then the seconds. So just remember the formulas on the first page. Minutes, 13 minutes is the same as saying 13 times 1 minute plus 56 times 1 second. So we'll just convert those using our formulas, and we'll be on our way. So 1 minute is going to be, let's see, I think I wrote that down. Yeah. I'll write them right here so I don't forget. 1 minute is equal to 1 over 60 degrees (1 second) is equal to 1 over 3600 degrees. And the way to get this is by converting minutes to seconds. So we're gonna skip that because I'm sure you guys know how many seconds are in a minute. All right, so change this guy. That'd be 13 times 1 over 60 degrees. Let me write that a little bit better. So I'm just using these formulas. 1 over 60 degrees plus 56 times 1 over 3600 degrees. And grab my calculator. These numbers will be rounded. 56 divided by 3600 is 0.015556 degrees. So add this up and round, see what we get. Should be 36.23 degrees. So we went from degrees, minutes, seconds to pure degrees. We converted this guy 13 times this formula here, 1 over 60. Converted the minutes by 56 times 1 over 3600. So these turn into decimals. We added them up and rounded. And that's it. Do you have any questions on that? You can do these pieces all at once in your calculator if you want to, and then round accordingly. I just wanted to show more steps so you can see that this is being converted to degrees. That's all.
I know for the exams you want us to show our work. Will we have to show this extra step or?
Well, I just want to see these, maybe this step right here is the main step I need to see. So here, there, to here would be the shortest. Shortest path.
Okay.
One moment. So what you need to do is just basically leave the 53 alone, because that part's just going to be the degrees part, the D. So take the 0.694 and convert that to minutes, and whatever's left over there, you convert to seconds. So anything that's in decimal form that's left during the conversion, you'll leave that for the next part. So let me show you what I'm saying. Let me write my formulas here. 1 degree is equal to 60 minutes. 1 minute is equal to 60 seconds. Okay. So remember, 53.694 degrees is the same as 53 plus 0.694. Both are degrees. So we're going to deal with the 0.694. So 53 degrees plus. So multiply the 0.694 times 60 minutes. Okay, let's use our calculator. 60 times 0.694. That will give me 41.64. I think that'll make more sense if I write it this way. Hold on a second. So I'm just going to focus on the decimal point. I'm not going to write that 53 over and over again. So 0.694 is equal to 0.694 times 60 minutes, which we said is 41.64 minutes. So then we focus on the decimal part again. Okay. So we're going to look at this piece right here. So 0.64 minutes is equal to 0.64 minutes. Let's put the minutes outside. Times 60 seconds. So I can get to seconds. Which will give me, according to our calculator, that is 38.4 seconds. But we're not going to go beyond seconds, so we're going to round that off to just 38. So our answer will be, final answer, 53.694 is equal to 53 degrees, 41 minutes, and 38 seconds. So we use this piece here. We use this gun, circle those instead. And that's it. We are now in minutes, seconds, sorry, degrees, minutes, seconds. there any questions about that?
So we're not gonna use the number 4 after the decimal point, right?
No.
Only the 38.
Yeah, just round. You would round up or down. So I'm gonna round down to 38.
Okay.
Because to use a 0.4, I'd have to go to like milliseconds or something weird, and
Milliseconds.
we're not gonna do that.
So
Usually, I'm sorry.
So if we have a number 5 over there, we have to go 39, right?
Yeah.
Okay. All right.
So would that make 41, 42 then?
No, because we took the extra part and converted it to seconds.
Okay, so that just applies to seconds since it's like the last step, right?
Yeah, we round at the very end.
Oh, okay.
Will there be a case where we only do degrees in minutes, but we do have to round up to the minutes?
Oh, if there's no seconds, I don't think so. Because you would need seconds. Yeah, I don't think there is a case where you would round minutes. Because in order to round up, you'd have to have leftover seconds, but you would have to have leftover here, but you're going to convert that anyway. So yeah, I don't think so. You might get a 0 seconds, but other than that, that should be the only scenario I can see.
Unless the problem just asked for minutes instead, maybe.
Yeah, it is. It maybe depends on the question too. That's a good point. Okay. Now let's move on to arc length. Find the length S of the arc of a circle of radius, let's say 60 degrees. No, I'm sorry. Radius should be a distance. Let's say 75 meters. Subtended by the central angle let's say pi over 6. No, 30 degrees. Okay. Now let me give you a picture. Arc length is, just in case you're not familiar. You guys see the PDF? Oops.
Yes.
Yeah.
Yes.
No, I lost it for some reason. One second. Click too many times. One moment. PDF stuff responding. There we go. Sorry about that. Okay. So right here, zoom out a bit. These are the only picture I have at the moment, and that's fine. So you have a radius from the center to the edge, and that distance on the edge of the circle is the arc length. So you're sweeping across some distance s. So we're trying to figure out what is s given the r, radius, and the angle is subtend. So how far did I sweep? What is that distance? Okay. So given this question, we have a really big circle, right? 75 meters. So all we have to do is use that formula and we'll find that S distance. So we said S was equal to, look at our formula. It's right here actually. I think it's R theta, but I'm paranoid. Yeah. R theta. Okay. So before we do anything, we need to convert degrees to radians. Otherwise, I don't have an actual distance because we need that unit, okay, in radians. So here we go. So first change this guy using your conversion factor. 180 over pi. Oops, that's not right. The way I remember is to put the one I want to cancel on the bottom. I'm trying to cancel degrees, so I will always remember degrees should be at the bottom. If I want to cancel pi, then pi better be on the bottom. So that will cancel degrees, leaving me with 30 pi over 180. These zeros will cancel. 3 goes into 18, 6
Pi over
times.
6.
Yeah, pi over 6. I left that all weird. But there we go. So just plug it in and we're good. S will be 75 times pi over 6. But this time, well, you will have to round to get an actual distance in meters. So all this will be in meters. The radians is technically unitless. So 75 times pi divided by 6. Okay, let's round to 39.27 meters. That would be the S distance. And use 5 meters going pi 6 degrees gives me an S. This is S right here. Okay. Do you have any questions on arc length?
So when we write the answer, do we have to do the little drawing of the
No, no, you don't have to do that.
It's just showing us.
Yeah, I just want to make sure you know later, like, what the heck is S, or what were we doing, you know, when you look back on this. But sometimes the homework will give you a picture, and you'll have to find the pieces yourself. Do one or two more examples, and we'll take a short break. Find the length S and area A. This time we give you a picture, I guess. This is 2 feet. This angle is pi over 4. Find S and A. So S, we said, was r theta. A is 1/2 r squared theta. Let me double check though. I don't trust myself.
Yeah, you're right.
Thanks. Whenever I write a formula, I double check because people use them. All right. Okay, so we have everything we need. Let's plug it in. So S will be 2 times pi over 4 feet. That will be something.
You slide your paper up.
Oh yeah. There we go. 1.57 feet. Now area. Is 1/2 times r squared times the angle. I should write an extra step in here. Okay. I'm going to write the word feet because we're squaring the feet. Which will give us feet squared because we're talking about area, right? So we need to have square feet. Okay, so this will be 4 feet squared times pi over 4. These 4s will cancel, leaving you with a 1/2 and a pi. 4 feet squared times pi over 4. That 4 is gone. Turns out to be the same except in feet squared. That's interesting. Pi over 2 foot squared. So this represents area. That represents that S distance. Is there any questions about example 6? Are called trigonometric functions. Or just call them trig functions. Of acute angles. So here we go. Sine of an angle theta is written as sine theta, which will be opposite over hypotenuse. Cosine of theta is written this way, cosine theta, which is equal to adjacent side over hypotenuse. Yeah, sorry, double checking the spelling, tangent. Also written as tan theta equal to opposite over adjacent. So here's your theta that they're talking about, this theoretical theta. So the side next to the angle, wherever you decide to put it, is considered to be adjacent. I shouldn't say where you put the angle. I should say the angle that you're referring to. So I'm talking about this angle. This is adjacent, meaning that this is opposite. But if I chose an angle up here, then this side would be the adjacent. You see what I mean? But hypotenuse doesn't change. Whatever. And to sum all this up, my trig teacher would tell me SOHCAHTOA, so I wouldn't forget which one's which. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent opposite over adjacent. That way I can't forget. Okay. So those are my main 6 trig functions. The other 3 are just reciprocals. I guess you can write it right here before I do the other thing. Just for consistency. Secant. Sorry. Yes. Cosecant theta is equal to hypotenuse over opposite. Secant theta is equal to hypotenuse over adjacent. Cotangent theta is equal to adjacent over opposite. So these are just reciprocals of the original 3. They just flip these guys over and you get 3 more. Okay, so we call these the reciprocal identities. So cosecant theta is equal to 1 over sine theta. Secant theta is equal to 1 over cosine theta.
Can you move it up a little bit?
And tangent theta is equal to, cotangent. Make this a little better. One over cosine. Cotangent theta is equal to 1 over tan theta. There we go. All right, quotient identities. So the tangent can be written as sine theta over cosine theta. Cotangent can be written as cosine theta over sine theta. There's some more formulas or identities. Okay. And the Pythagorean identity is this guy. This is probably the most important one. It's going to derive a bunch of others later. Sine squared plus cosine squared theta is equal to 1. You know what? I'm going to make all 6 on the next page. That'll be better. You guys cool on this page? You can wait a bit. There's no rush.
Almost done.
Let's see what we got. Okay. Find the value of the 6 trig functions of the angle theta in this figure. Yeah, that's fine. Yeah, we'll do this way. $9.40. So we need the hypotenuse in order to find most of them. So let's solve for that first. So we know since this is a right triangle, then I'm allowed to use Pythagoras' theorem. The sum of the sides are equal to the hypotenuse, right? Square of each leg is equal to the square of the hypotenuse. So it doesn't matter which one you call A or B, just square both and add them together, solve for C. So 9 squared plus 40 squared is going to be C squared, which means C is equal to the square root of whatever the heck that is. 9 squared plus 40 squared. I skipped a step there. Hope that's okay. Let me know if there's any issues. A second, square root of 9 plus 40. this will be 41. And the hypotenuse is 41. So now that you have all three pieces, using the definitions of sine, cosine, etc., you should be able to find all 6 trig functions. Okay? So here we go. So sine, SOHCAHTOA, sine is opposite. So opposite to the angle, here's theta, opposite over hypotenuse. The sine,
Can you
is
lift this? Thank you.
that better? Okay. So sine is opposite over hypotenuse, right? Now, cosine, that will be adjacent over hypotenuse. Tangent will be opposite over hypotenuse. No, sorry, over adjacent. Yeah, there we go. So once you have the first three, just use the reciprocals and you'll be good. So we know that secant will be a reciprocal of cosine. Cosecant will be the reciprocal of sine. Cotangent, reciprocal of tangent. So just flip them over. This is 9 over 40. 41 over 9. 41 over 40. Yeah. It should be it. Double check. Yeah. That's all three trig functions. There are 6. Do you have any questions about this problem? Okay. All right, I think we're just about out of time. Let's see if I have time for another one. Yeah, we'll stop here. So on Wednesday, we'll finish 7.2 and 7.3, and we'll go from there. If you have any questions, let me know. I'll stick around for a bit. And if not, I'll see you Wednesday.
Now we have homework on this 7-2.
Yeah, they're all assigned already, but I'm gonna edit 7.2 right now. I'm gonna double check that it's not too. What I like to do is delete the weird hard questions that are
Okay.
unnecessary, since what I'm doing right now. But 12.5 and 7.1 are good to go. If possible, I'd like you to finish both of those by Wednesday. 7.1 is not too long. 12.5 is the one that takes a while because there's so much algebra.
You extended 12.5?
It's 3x squared over x minus 5 squared times x plus 5 squared. All right, so these are both repeated.
You want me to
So,
stop sharing?
Yeah, you can stop if you like. It's fine. So here we go.
You okay?
Yeah, that's fucking up my brain because I'm trying to keep up.
All right, so we got to count up to the number of powers, right?
Like, okay, so say like they put you to sleep.
Mm-hmm.
We jump into your.
Someone has an open mic. Sorry.
You're already in your subconscious. We're not going to put and jump back into your subconscious. So they've already jumped at least 3 times.
Mm.
They have to be able to at least 4 different subconscious already. Now they're in this new subconscious, which keeps like changing
I
everything.
think it's crucial.
Yeah. Okay. So here we go. So we're going to multiply both sides by this LCD, right? So we'll end up with just a 3x squared on this guy. Is it okay if I skip a couple steps, or you want to see detailed pieces?
Mainly, my problems happened when
When you get to
in the
the system?
distribution and whatnot, because it just gets pretty complicated.
Okay, got you. So I'll skip to that part then. So you'll multiply both sides by this guy, so you'll end up with a times x minus 5 times x plus 5 squared plus b times x minus 6 plus 5 plus c times x minus 5 squared x plus 5 plus d times the x minus 5 squared. So when you do all your multiplication, that multiplying both sides step, you get to here. And then we got to do some ugly algebra, but it's just how life is and sucks sometimes. I'm going to expand the ones with the squares first, and then I will do a FOIL to be safe. There we go. So x plus 5 squared will be x squared plus 10x plus 25. This guy will be the same thing, so plus b times x squared plus 10x plus 25. I'm using a formula to expand that FOIL there. Because remember, a plus b squared will always be a squared plus 2ab plus b squared, right? So we use that here, it'll speed things up. So c times x squared minus 10x plus 25. I'm going to have to write in the second line because this is a long question. Okay, plus d times x squared minus 10x plus 25. That's not going to be pretty at all. Okay, here we go. I'm not going to write the 3x squared just for space. No, that's fine. So here we go. So a times all this nonsense, we will have x cubed plus 10x squared plus 25x minus 5x squared minus 50x so minus 125. So that's all going to be multiplied by a. Okay, b is not too bad, already there. Okay, so b is good. Keep going. C times this expansion will be x cubed minus 10x squared plus 125. Double check. Yeah. No, it's a lie. That should be 25x. Now distribute the 5. That would be plus 5x squared minus 50x plus 125. Okay, now the b, another easy one. Dx squared minus 10d plus 25d. I forgot my x there. And xd plus 25d. Oh man, you gave me a nasty question, bro. Ax cubed plus a 10a x squared plus 25AX. You know what? I'm going to combine them first. Cool if I skip a minor step here? I'm going to combine the like terms inside the parentheses.
No worries.
Just because I'm almost out of time. AX cubed, 10x squared minus 5 would be positive 5AX squared. These guys are good. 25 minus 50 would be negative 25AX minus 125A plus BX squared plus 10BX plus 25B. Okay. Over here, we will have plus BX cubed. Negative 10 plus 5 is negative 5BX squared. These are gone. 25 minus 50, negative 25CX plus 125C. And the last guy is not too bad. So at this point, we got to pray that we did not make a sign error at some point. Because then we got to double check all of this. But if it's set up good, we're just going to group the ones with the same power. And then that will create our system, right? So we only have 2 cubed terms. So we're going to have A cubed, so that'll be this A here, plus B, plus C. Only these guys have the cube. And there is no cube on the left, so it's equal to 0, right? That part makes sense?
Yes.
Okay, so now we go to the squares. 5A, so that's square there. There's a square. There's another square. So it's that guy, and one more square. That's equal to 3 because there is a squared term. Now back to the x terms. Negative 25A, 10B, minus 25C to the x, minus 10D equal to 0. There is no x term, right? Okay. Now the constants. We have negative 125A, 25B, plus 125C, plus 25D equal to 0. So, as a matrix, if I didn't make any errors, this would be 1, 0, 1, 0, 0. So there's one A and one C. There are no B's or D's in equation 1, right? Next one has a 5 for the A, a 1 for the B, a negative 5 for the C, 1 for the D. Next one, negative 25, 10, negative 25, negative 10. 3, 0. Last guy would be negative 125, 25, 125, 25. And that would be your matrix. So whenever you're missing a letter, you need to put a 0 for that section. Just remember this is the A, B, C, D column. Okay. And then you solve it with the calculator or an app, because doing that by hand would take probably 20 minutes. Which is fine, just not right now.
I had a question on how to put the matrix in my calculator.
Okay.
I
What happened?
found Okay, I know like where matrix is, it's like the number 7 on mine.
Let's see.
Can you see it?
Okay, on yours, let me click on your screen. You have the Inspire CX. That calculator can do it. It's just the steps will be different. I'll send you a video on how to do it.
Okay. Yeah, I tried to do it. I have that. I used to have your calculator.
Send me an email so I don't forget. What'd you say? Sorry.
Oh, I said that I used to have that calculator.
Oh, the 84?
Hmm.
Well, yours is better. It's just more, it's just different. And
It's
you have to
fancy.
learn new stuff. That should be. Let's see if I get this guy's answer or not.
Hmm.
101003. Okay. 51. Negative 5. 1. Negative 25. 10. Negative 25. Negative 10. I'm hoping and praying a little bit that this is what they got. I got for A, 3 over 20, B, 3 over 4, C, negative 3 over 20, D equals to 3 over 4.
That's right.
But if it's not exactly the same, then I have made one small addition error up here. But
It's exactly the same.
okay, that's good. Did the steps make sense though?
Yeah, it just this homework problem really highlighted the importance of knowing both methods because I mean you can see that's probably like 10 minutes longer than what the other method would have been just because of all the distribution and gathering.
Yeah, sometimes the other side is really cool, but sometimes they'll leave you in a spot where you can't find one of them, and you have to end up expanding things. Yeah, I recommend knowing both if you can. But if you have, or at least this guy, this method.
Right.
Do you want us to